Okay guys, welcome to day one of online instruction. We're going to start this first section of the unit with just a basic review of Pythagorean theorem, which you've seen before. If you don't already have your 8-1 notes out and ready to take notes, pause the video and find that paper. We're going to do just a couple of slides a day, kind of baby step our way through it, make sure that we get all the different types of problems that we might see involving Pythagorean theorem over the next few days. This is one thing we really have to have a good mastery of, because it's going to be involved in some sort of way in everything else we do for the rest of the year. Okay, so moving right along, the basics of the Pythagorean theorem are that they give us a tool for solving right triangles, solving for missing sides of right triangles. So the theorem itself states in a right triangle. Okay, we start with the right triangle. The square of the length of the hypotenuse is the sum of the squares of the lengths of the legs. So we can get a more light on the subject here. So we have a right triangle. The two legs are the two sides that form the right angle. Depending on how that triangle's turned around, legs could be anywhere in the picture. So to make sure you know those down correctly, you're looking for the two sides that make the letter L. L is for legs. Two sides that make the L are the legs. It doesn't matter which is which. We normally label those A and B for side lengths. Doesn't matter which one's A, which one's B, but the legs must be A and B. The hypotenuse is the longest side. It's always opposite the right angle, and we always call it C. And the Pythagorean theorem, you've seen it before in classes in the younger grades, is A squared plus B squared equals C squared. And we use this as a formula to solve for parts that are missing. There are three different ways that can happen. One is if we have really nice sides that are whole numbers, or sides that we can use decimal approximations for measurements of. There are special cases called Pythagorean triples that we're going to look at in the next video. And then we also have to learn to solve and leave answers in a radical form, an exact form that's a little bit messier that we'll get to on the third day of the notes. For today we're going to keep it simple, and we're only going to look at the ones for which we get whole number answers, or we can use a decimal approximation. So that said, go on to the next slide, and we'll jump right into examples. It only works for right triangles. If you do not have a right triangle, do not use Pythagorean theorem. You would need something more sophisticated than A squared plus B squared equals C squared if you didn't have a right angle. So in this first triangle, the legs, the two sides that form the right angle, are X and 45. Make sure you identify clearly which two sides are your legs before you ever start using your formula. The most common mistake students make is mixing up a leg and a hypotenuse in the formula. So legs come first. They're on the left side of the equation together. So X and 45 are the legs. We could say X squared plus 45 squared, or 45 squared plus X squared if you want the other order, it doesn't matter, is equal to, C is always the hypotenuse, so 51 squared. The hypotenuse is the longest side. It should be on the side by itself. The two shorter ones, two shorter legs, should go together in such a way as to equal something about the bigger side. Then we do some mathematics, do some squaring. So we grab our handy calculator, and X squared we bring down. 45 squared, we have a square key here. If you don't have this calculator at home, there's a squaring key. I think it's an A squared key. It works the same way on that free online calculator that I gave you a link to. So square that and we get 2025. That's equal to 51 squared. 51 squared is 2601. Two more steps in the algebra will be done. We'll subtract 25 from both sides. So minus 2025 minus 2025. X squared equals 2601 minus 2025 is 576. And then a square's inverse operation is a square root. So we're going to take the square root of the left side, square root of the right side. We only need the positive square root. Square root and square will undo each other and leave an x. And the square root of 576 is 24. So the missing side is 24. There are really only two types of problems that you have to be able to work. One is a situation where you're given a hypotenuse and a leg and you have to solve for the missing leg. This is the longer of the two. If you're given the two legs and have to solve for the hypotenuse, that's a bit shorter on the algebra end. And that's what we're going to see in the second example. So we're going to scoot the calculator over and take a look at this one. So on this triangle, we've got it turned around differently, but we're gonna nail down the legs. The legs are the two sides that form the right angle. So that's 30 and 40. So 30 and 40 are my A and B in any order. C has to be the X. So 30 squared plus 40 squared equals X squared for the third side. 30 squared, well, 3 times 3 is 9, so 30 squared should be 900, that's right. And 40 squared, 4 times 4 is 16, so 40 squared should be 1600 equals X squared. And you could go ahead and add the 900 plus 1600 in the same step and skip this intermediate step. 900 plus 1600 is 2500 equals X squared. If you want to skip from the first to the last, you could do a 30 squared plus 40 squared, since they're on the same side of the equation, and skip to 2500 in a single step. How convenient that is depends partly on what kind of calculator you're using. Alright, last step. Take the square root of each side. Square root of x is x in this case, and the square root of 2500 is 50. So x equals 50. Okay, so these are the bare basics. These are examples where you get really nice numbers for answers. So not a lot of really interesting things going on. What we really want to nail down this first day is just how to do the algebra when you're solving for a leg versus how to do the algebra when you're solving for a hypotenuse. The setup is similar, but how you solve it is a bit different. Alright, if you flip to the next slide, we get a whole different topic here. This is going to be tomorrow's video, so we'll stop there. So your homework for today is to find your Unit 8 practice packet. And for today, you're going to complete page 1. And after you get that completed, you're going to take the quiz on Schoology, which is basically just a spot check from that worksheet. So it'll ask you some questions about that completed worksheet, and that will give you your daily quiz grade for this first day.